Perfect. All right, so some background on hazel dormice. The hazel dormouse is a small nocturnal rodent. It's mostly arboreal, using aerial pathways in the tree and shrub canopies to move around its home range, and they're really reluctant to cross the habitat gaps at the ground level. They need a range of plant species to provide food throughout the year, throughout their active season, and their optimal habitat is in woodlands with a dense understory, dense scrub, and then in the UK particularly in the connecting hedgerows between their different habitats. In the UK, they're a legally protected species, meaning they have to be considered where they might be impacted by any kind of development, including transportation. So some of the main threats to dormice are changes in habitat management as well as fragmentation. They rely on the connecting arboreal habitat to find enough different food. They rely on the connecting habitat to find enough different foods throughout the year for dispersal of their young and for connecting various populations to ensure genetic diversity. So with all these increasing linear infrastructure projects, it fragments their habitat and impacts them. So there's been a number of previous attempts to create bridges for dormice in the UK in the past, but there has been some issues with them. So many of the small bridge designs haven't been science-led. So the only bridge that's actually been shown to have dormice using it was a really, really large green bridge. Sorry, it keeps moving automatically on me here. It was a really large green bridge that basically had been planted across, and it was actually shown to have dormice breeding on it. So it was used, and that's fantastic. But that's a really large project. It's millions of pounds, so it's not really viable at a small scale and all these other smaller projects. So a little bit of background on our bridge. We partnered with the People's Trust for Endangered Species in 2015 to make sure we had a design that would actually work before we started putting it on different projects in real life. So the design's based off of a Japanese design by Dr. Shusaku Minato, and we constructed a similar bridge in the UK to trial. So we designed it with the behavior of dormice in mind. So there's multiple entry points, there's lots of shelters along the bridge, and lots of different options that they can climb on throughout the structure. The bridge was installed on the Isle of Wight and monitored over the entire 2016 active dormouse season. So dormice were actually found using the bridge only about 9 hours after it was first installed, so we were quite impressed with that. And then overall, in the entire season, they did show a strong preference for using the bridge over crossing on the ground, and our research was published in Conservation Evidence in 2019. So then we wanted to be able to apply this design to real projects, but in the UK, the road safety standards are very, very high. So we met with some highways engineers to upgrade the design for compliance. We changed to longer lasting materials and changed the design a little bit while keeping the general structure that had been proven to work more or less the same. We did also replace that trial bridge on the Isle of Wight with these upgraded designs. It did find dormice still using them up to the last year of monitoring, which was in 2019. We also came up with 2 overall installation methods. So there's the standalone design, which, as its name is, it stands alone, so you can put it sort of anywhere. And then there's also the retrofit design, and that's where that can be retrofit to existing infrastructure along the roads. So first I'll talk about the standalone bridge. So it can be installed independently supported by posts. So there's some benefits of this design. Obviously, it's more flexible in the location, so it can be built at the place best suited for the habitat in that area. An ideal place might be where multiple habitat connections come together to benefit a much wider area. There are some limitations, however. So the length of the bridge is limited to about 24 meters without any central posts, and that's using the stronger square design as well. And because of the high road safety standards in the UK, the bridge ends need to be placed back about 4.5 meters from the side of the road. So automatically you're already adding about 9 meters onto the length of any bridge across the road. So it does add some restrictions there. And then the second type is the retrofit design. So the bridge is installed directly to existing infrastructure, such as a culvert, an underpass, or a bridge overpass. The features of this design are a little bit different than the standalone. Obviously, if it needs to be retrofit to existing infrastructure, you're really limited to the areas where that infrastructure already exists. And then you need to make sure there's also suitable habitat for the dormice in those same locations. Now, from a technical perspective, there are some benefits to this option. There's no limits on the length of the bridge as long as you can put a fixing onto the infrastructure every 5 meters or so. So that means you can go much longer lengths on the bridge. And then there's more flexibility in the connections. So the bridge can be split into multiple areas, sort of branching off. So for example, if you've got 2 roads crossing each other, then you can connect the habitat on all the different corners. Okay, so now I'm going to move into the case studies. The automatic changing of the slides is keeping me moving here. So the first case study I'd like to discuss is the first commercial bridge that was installed. It was as part of a project to build an underpass for an agricultural access road in South Wales, where dormouse habitat, the hedgerows, were being disconnected on either side. So for this project, we used a square bridge that was retrofit to the roof of the underpass with fixings about every 5 meters. At each of the ends, the bridge was angled over the wing walls into the habitat on either side, and then it was planted up following this, because this was a completely new infrastructure they were building, so it was really down to the bare ground, and they had to completely plant it up after to connect into the wider habitat. Now, bespoke engineering designs were created, but the technical requirements weren't nearly as high, so it was easily installed. There wasn't really too many issues with this, so it was a really good first project to get in to start with. So that brings me to our second case study that was a little bit more complicated, the M1 Smart Motorway. So the M1 is a motorway to the north of London, and they were widening the road from 6 to 8 lanes, which involved some vegetation removal on the sides. There had been dormice found there during the ecology surveys, so 2 dormouse bridges were proposed as mitigation across the motorway that would reconnect habitat that had been disconnected for quite a long time. At these lengths, the retrofit bridge is the only option. So 2 existing infrastructure were chosen to connect the habitat either side. One of these was a bridge overpass, and the other one was an underpass, and both of these were used as farm access roads. So there was a number of constraints that did make this project a little bit more challenging than the previous one. So first is the project had a limited timeline. Under their dormouse mitigation license, they had to get this in within the correct timings of the season. So with that in mind, they also wanted to keep the technical approval category to the lowest possible to make it go a little bit faster through. At the same time, this is a very major motorway in the UK with extremely high safety standards. They also had multiple stakeholders in because it was such a large project, including the farm landowner on the side there as well. And each of the stakeholders had their own opinions and different feedback. Okay. Some other constraints were the location and space itself. So these roads had public access, so I had to consider the vandalism as an issue as well. And then also the space constraints. So if you take a look at the photo on the bottom left, to keep the safety issues, the bridge had to be installed on the inside of the rail, but it had to be raised off the ground for the dormice. And then you can also see on the bottom left that road still had to be used by agricultural machines. So it really left a limited amount of space that it could be installed. So in the end, the project was completed with about an 8-month turnaround. To meet all the constraints of this project, we did have to adjust our design quite a bit. So everything had to be fixed with bolts and anti-vandal nuts. As well, we worked with the engineers and the authorities to create new installation methods to fit all the different needs of the project. So this project did differ quite a bit from the previous one, and we've taken a lot of that, the things we learned from that project, on board going forward. So on all our future designs, we've kept the same fixings and upgraded anti-vandal fixings and materials that were approved for that project, and we've kept that as a standard going forward. From everything we've learned over the past few years, we also compiled them into a new best practice guidance. So it provides advice and summarizes the entire process in detail to get one of these in, right from the planning stages all the way through to the post-installation monitoring of the dormouse populations. Now, we chose to include the technical aspects as well in the planning. So I know most of us here are wildlife biologists and a little more ecology-minded, but the technical aspects really affect how these projects are implemented. So it's really important to consider them in all the planning as well. Okay. So I'll bring it to the end. Since these case studies, we've had some additional projects. We just had a new bridge installed in Denmark. So I'd just like to say thank you for listening. We do have our best practice guidance available online, or you can come chat with us at our exhibit stand over there. Thank you.
I have again, I would say, a more synecological question. Where we find dormice, we mostly or nearly always find other species that are also in need of defragmentation. Mm-hmm. And the question is, why do you concentrate on such a species-specific solution and thereby hinder defragmentation for a multi-species? Yeah. So if it's an excuse for road builders and so on, not to look at other species.
Yeah. No, that's a good question. In the UK, part of that is just the species that are particularly protected there. Now, in our trial, we did also find it being used by red squirrel, so it's actually being, in some areas, it's being proposed to connect red squirrel populations as well. However, in the UK, most of the red squirrel populations are really restricted to a few areas, so it's not as expansive there. Now, we've come there from the UK, but we're very open to using it for other areas and having it used as studied to see what other species would use.
Even can bring ground beetle species from one end to the other. So yes. I really disagree with such species-specific solutions.
Okay.
What about the cost of maintenance of all these facilities?
So with the upgraded materials on it, the intention is that it has a 30-year lifetime with very little maintenance. Now, we do sort of recommend how often to inspect it, but it's been created so that it really shouldn't need any maintenance at all. The structure is powder coated, and the intention is that it's supposed to be low maintenance.
Thank you.
Okay. Thank you very much.